Hello, and welcome back to the continuing lecture in business math. In our last class, we discussed the one of the accelerated depreciation technique, or one of the accelerated depreciation methods, which is called sum of the years digits method, or rule of 78, right? Now, we discussed how we make an adjustment in the partial year depreciation as well. So we have only one mathematical method left. And actually, there is non-mathematical method, which is, I also mentioned this in the last class, the declining balance method. Modified accelerate cost recovery system, which is the non-mathematical. But what we are going to talk about today is the declining balance depreciation method. Okay. Now, declining balance method is basically similar to straight line depreciation method, but actually the difference is that it is the value, right? It's the book value that is declining at a accelerated rate. So let me give you the preliminary setup for this method. First, this is not necessary, but let me get rid of something like this. So suppose we have an asset, right, that is simply move the whole thing to the right, to the left. Suppose we have a $13,000 asset, and the salvage value is $750. Service life is 4 years. 4 years is, of course, according to the textbook, right? The asset is, defined as like 4 years. In reality, you don't actually see a 4-year asset. It's usually 5 years and above. The minimum is like 3 years. But so you don't actually see 4-year asset. But just hypothetically, if there's a 4-year asset, salvage value $750, then we would look, usually then the depreciation rate will be 1 over service life, okay, which should be 0.25, but because rate is percentage, right? We're gonna use percentage, using 2 decimal places, regardless, right? But then normally, so that means 25% is depreciated every year. But in declining balance method, right, we use a multiplier, right? And so the multiplier is a number between, a multiplier of 2 is, basically then, what does that mean? 2 times 25%, so 50% will be, depreciated each year. Obviously, if 50% is depreciated, then acceleration depreciation is accelerated, right? But then the multiplier has a range. It's not like any random multiplier. In other words, then using a multiplier of 4, what does that mean? Using a multiplier of 4, you can depreciate even within the first year, right? If you use multiplier of 4, so they don't allow multiplier any random number as a multiplier. The maximum is 2, and it's got a range. So it must be greater than 1. Obviously, if it is not greater than 1, then there is no point in using a multiplier, right? So the multiplier is the ranges between 1.25 and 2, and in the increment of 0.25. Okay, once again, the multiplier is within the range. Multiplier ranges between 1.25 and 2, and the increment is by 0.25. Okay, so then the lowest multiplier is 1.25, and then 1.5 and 1.75, and the highest multiplier is 2. Okay, then in this example, we will okay, let's see if I get rid of this page number. I make it, oh no, why is it nothing is standing in the way. Partial there, something is not everything is okay. I don't understand why. Maybe down there. Okay. Okay. No big deal. Yeah, that's a formatting thing. I just don't want this column to be too wide. But anyway, so normally it would be 25% a year, but using multiplier of 2. In this case, the multiplier is 2. Then each year, 50% will be depreciated, right? In other words, you can simply do that by, okay. Now, I can, here, I can make it better. Let's say I can, let's say I can make multiplier a random thing, not 2%. I'll just, let me turn this into a, make it 2. Okay, then if this changes, right? So here, what I can do is I can refer to that cell and lock it, right? Drag it down. It's going to be 50% every time. And then if multiplier is no then 1.75, everything will automatically change, right? But let's leave it like that. And then what is being depreciated? Now, in this case, in declining balance method, it's not depreciation base is it's not the depreciation base, but the it's the book value at time 0, right? Book value at time 0 is basically book value at the beginning of the year, right? I can change this notation to time T0, and then this will be then T1. But then, in the second year, then this will have to be T1. So instead of using T0, T1, I just, excuse me, I just keep using, a beginning of the year, end of the year. Okay, then the first year at the beginning of the year, the book value, of course, at the beginning of the year is 13,000, right? And 50% of that will be depreciated in year one. 50% of that is simply that times that. And the accumulated depreciation or cumulative depreciation, right? And first year is just itself, right? It's just itself. And then the book value at the end of the year will be the difference between what is the book value. It's always at the end of the year. It's always the uh, cost minus the cost minus purchase cost minus accumulated depreciation. But in this case, the purchase cost is book value at the beginning. So you simply subtract that, and then subtract cumulative, right? And then at the beginning of year two, book value at the beginning of the year is exactly book value at the end of the year. So I just point to that, right? And then I drag it down, okay? See what I did was, and then I drag it down, and then every time is 50%. And accumulated depreciation is always, accumulated depreciation is the current year's depreciation plus previous years, right? Cumulative depreciation. And you drag it down, right? And book value at the end is just the same, beginning, book value at the beginning, minus cumulative depreciation, and so on, okay? And then, again, year three, right? I already dragged it down, so it's automatically pointing to book value at the end. And 50% of that will be depreciated, cumulative depreciation. I already dragged it down, so it's like that. Now, interesting thing is, in the last year, so book value at the beginning will be this, and the 50%, now our question is that the 50%? I mean, now let's think about it. Let me delete all of this and think about it. And hold on to, so if you drag it down, okay, that would be half of that. And by dragging down, right, this will be the cumulative depreciation. And by dragging down, what's it going to be? What? Negative? Oh no, something's not right. What? Yeah, isn't that right? Why? Because you cannot have a negative book value. It would have to be either zero or the salvage value, right? So this something's not right. Yeah, where did it go wrong? From here. Why? If you just mechanically follow, in the last year, this will be the depreciation amount, and this will be the accumulated depreciation, then you cannot end up in the salvage value, right? So what do you need to do? You need to make an adjustment. So let's think about it. What should be the adjustment? If you think about it, what in the last year, right? Think about it. To end up in the designated salvage value, right? You would need to depreciate the book value at the beginning. In other words, regardless of the structure, the format that was going on. In the last year, you would have to depreciate the difference between the book value at the beginning of the last year and the salvage value. In other words, this much needs to be depreciated, right? And then accumulated depreciation will be like this. And then, oh, what is wrong? B48 cannot be B48. Something's not. But you know what should be done. It's not B48. It should be this, right? B50. But things have been not doing well from here. First, B47 minus E47. And then, one thing. Book value at the end of the year is always what? Yeah, there are two ways you can do it. One, book value at the end. Book value at the end of the year is always purchase cost, right? You have to lock it minus accumulated depreciation, right? Okay, and then you drag it down. There you go. You end up with the salvage value, right? And then what else can you do? Here's another way of doing that. Also, you can do book value at the beginning minus that annual depreciation, right? Makes sense? And then in year 2, because you have, decreased, book value, right? Then simply, subtracting that year's depreciation would, because this is a result of already, accumulated depreciation, right? Simply subtracting this would get you to the end of the year and dragging it down, right? So you see what has happened. Let's do this again. So let me insert a couple of a couple of rows, and then let's make it 80-year asset, right? If this is 80-year asset, and let me get rid of any borderline. Okay, and then 80 years. And the salvage value, let's make salvage value completely something like a scrap metal value. And let's make this asset more expensive, something like 135,000, right? And then delete. Let me clean up everything. So let's say we are starting with a clean slate. Okay, clean slate. Okay, let me get. Okay. So if it is 80 years, right, the rate would be annual depreciation rate would be 1/8, so 12.5%. Now multiplier, let's use multiplier of 1.75, right? It would be either 1.25, 1.5, 1.75. And then, so book value at the beginning of the year is this, right? And depreciation rate is this. Hit F4 to lock it, times a multiplier, and hit F4. And use two decimal places, right? Always 2 to 3 decimal places, right? And the depreciation expense for the first year is then this times this, right? And then cumulative depreciation in the first year is just itself. And the book value at the end of the year is then using, the fundamental definition of book value at the end, purchase cost, which is always book value at time 0, and you lock it because you're gonna drag it down. Minus cumulative depreciation, right? And in the at the beginning of year 2, book value at the beginning of year 2 is the end of year 1 book value, right? And so from there on, we will just drag it down. I will drag it down all the way. Drag it down all the way. We got this, and let's say something. Oh, here I forgot to make adjustment. From year 2, you need to cumulative depreciation is this, right? You drag it down. So now we got it like this. But then here's the problem, right? You cannot leave it like that, right? Why? So this part I will also use let me use this. Oh, no, not there. I just wanted to. Okay, no highlight there. Now this is the part you have to make adjustment, right? Yeah, maybe I'll use yellow there, and the rest of them, because it's the rest of them, it's easy, right? It's relatively easy. Oh, that's too dark. Okay. Now then, let's think about it. Regardless of how many years the life is, the basic reasoning is the same. The logic is the same. I hate to. Okay. I don't like to be very verbose, right? So cumulative depreciation, right? And then give it center alignment, right? Okay, there you go. So you want to end up in 150 as the book value at the end. What does that mean? Then in the last year, you would have to depreciate the entire. You would have to depreciate the whole amount, the entire. I mean, the difference, the entire difference between last year's, beginning of last year's, final year's book value and the salvage value. So then you would simply take the difference between the two, right? It's going to be like that. And then you drag these two down. Voila. You end up with the salvage value, right? There you go. So the depreciation is complete and perfect. Now, if we change the multiplier, it's going to automatically adapt, right? Suppose we change the multiplier to 1.25. Of course, the less each year, less amount will be depreciated, right? If you change the multiplier to 2, most amount will be depreciated. But this way, especially when the multiplier is 2, it's called double declining balance method. Double declining, right? Because the it is double the normal depreciation rate, right? But they say, of course, companies would prefer to use. Which multiplier do you think the companies prefer to use? Well, of course, they will want to use the highest number, so 2, right? Because what are they doing? They are doing the accelerated depreciation, and as long as they are doing the accelerated depreciation, they want to do it. They want to depreciate ASAP. Then obviously, or if the life is already life is already given as 80 years, you cannot do it faster than that. It will take 80 years, but most amount gets depreciated in year 1. I mean, the earlier the time, the more the depreciation amount, right? So that's the rationale, or that's the logic behind the reasoning behind declining balance method. And somehow I've heard some accounting people talk about double declining balance method as if it is some kind of magic. No, nothing magical about it, or nothing powerful about it, or as if it's powerful, more powerful than double declining is more powerful than the multiplier of 1.75 or any 1.5 or anything lower than any multiplier lower than 2. It goes without saying, and as if it is some mysterious trick. No, it's not a mysterious trick or technique. It's just a technique that's under your control, right? And the way it is built, right? This lends itself readily. Amenable to partial year depreciation, because what is the difference between full year depreciation and partial year depreciation? And of partial year depreciation, you have to make an adjustment, right? But then in this declining balance method, anyway, even in the full year depreciation, you have to anyway you make adjustment, right? So partial year is nothing new. It's just simply it's an extension of the adjustment you still make in the full year. But here, one more thing. Now, as I've been telling you, always is the good form. It's always the in a matter of good form, which is, when I say good form in the context of depreciation, what I mean is, um, you must end always with the salvage value as the book value at the end, right? And if you don't end up in the salvage value, then that is not a good form. It's not, it's very sloppy, right? It's a sloppy way of doing it. And again, this textbook, the book is giving you the sloppy way. They don't make adjustment at the end. They are just happy, doing the double declining balance method, and they never. So the book is, not like this. If you, and I'm warning you, if you follow the book, then uh, you'll get it wrong. You'll get penalized. Of course, it's only natural you get penalized if you do it wrong, right? You don't tell me, I follow the book. The book is sloppy. I've been telling you over and over. Follow what you were taught, in this class, exactly the way you were taught in this class. You understand? And I'm showing you. I've been showing you the way the technique to make it end up in the salvage value, so that the depreciation schedule would be complete and immaculately neat, right? Neat and immaculate, right? That is, uh, what it should be, right? How it should be. Um, Now, so let's think about book value. This is just additional, right? So let me take it apart. So we can calculate book value at the end, also this way. I showed you before. If you want to simply start from book value at the beginning, you simply subtract the annual depreciation expense in that year. Oh, that was what? The 40, oops, the 47, right? Hit enter. And then you drag it down. Okay, we're good up to this point. And of course, then, the last year, you will simply, it's the difference between beginning of the year and uh, depreciation, right? For that year, you'll end up with, right? You'll end up with the salvage value. Okay, great, wonderful. Um, so the last thing is always the uh, housekeeping. You make it, look nice by using a outside border, big outside border. Now, suppose we are doing a partial year in this case, right? Partial year. And what was the assumption? I hope to. Oh, okay. So let's do it like, in the straight line depreciation. Okay. I thought I used something like, where is it? Wasn't it? I don't think it was saved because I did. Oh yeah, here I have this. You can have, right? You can make a separate. Okay. Suppose, this asset was purchased in, so it's a 5-year asset, uh, $10,000 purchase cost and salvage value is 0. Service life, 5 years. Okay, then we will need, okay, let me move this around. I'll take it, uh, maybe here. So what do I need? Rate and, multiplier, right? And suppose we have, multiplier of 2. Now, and suppose we purchased this asset on April 1st, right? And then in the first year, think about it. Let's do this from the scratch, right? I'll delete everything. And I don't like to be verbose, right? Okay, no. So book value at the beginning of the year is 10,000, right? The depreciation rate is, of course, is normally 20%, right? Because 1/5, right? But multiplier is 2, so it's going to be 40%, isn't it right? Multiplier is, right? Using 2 decimal places. And then the depreciation expense in the first year is this times this. But then, think about it. The asset was owned only for 3/4 of a year, right? 3/4. So we have to make an adjustment. Instead of writing in, 3/4, right? Once again, that makes it, that's hard coding, and hard coding can be used only once, right? Because it cannot be, once you hard code the formula, then it cannot be replicated, right? So instead, we will do simply, T1 minus T0 over 65. Okay, and then that's the depreciation in the first year, and accumulated depreciation is just itself. And then book value at the end of the year is always the purchase cost, so you lock it, minus cumulative depreciation, right? And in year 2, book value at the beginning is book value at the end of year 1, and then you'll drag it down, right, for later. I can drag it down later, but all together. Now, depreciation rate is, of course, always 40. I'll just drag it down up to this point. And what about this? Yeah, depreciation. So let me drag it down like the whole thing there. But we'll need to make an adjustment here, right? First of all, I should have done it from here. E58, that must be also locked, right? Okay, and then you drag it down. Now, depreciation in the second year is book value at the beginning times, and we don't need this anymore, right? Right? You don't need, adjustment. You make remember in the straight line depreciation method, in the for partial year adjustment, you make that adjustment only in year one and only in the last year, right? So you don't need to make adjustment here because the double declining balance method is built up. It's basically an extension of the straight line. And then in cumulative depreciation, don't forget it is literally cumulative, so you'll have to add in what was accumulated in the previous year, right? And there you go. And then from here on, you can just simply drag down everything. And then we need to remember we need to make adjustment in the last year, so that we would end up in the salvage value. So first, I'm gonna highlight that, and then I'm gonna get rid of all these, border lines, and I'll put it back in later. So all of these, what is the depreciation in the last year? Well, depreciation in the last year will be the difference between the beginning book value at the beginning and the salvage value. And you might wonder, do we need to do that? Because in this case, salvage value is 0. That's not going to make any difference. You still need to do it this way. Why? What if salvage value is positive? What if there's something in the salvage value, right? So to be able to, I've been telling you over and over, the model should be universal. It should be universally applicable, right? So you can, so that the model can adapt to any any other, any environment, any business environment, or any depreciation environment, right? The model should be consistent, and in terms of formula, right? It should be consistent and it should be universal, right? So if we do that, okay, there you go, and then from there on, it's all the same. You drag it down, and you will see. Oops. 0 for the salvage value, right? Okay, which is originally predetermined salvage value, right? Now, but again, let's see. What would you? What if the salvage value was something else? It's going to automatically adapt, right? If the salvage value was like $75, you'll end up with $75. What if the purchase cost was $210,000? It's going to automatically adjust. If the cost was 210, right? Thousand, salvage value may be a little higher, right? 175. It's going to end up in 175 exactly. What if the multiplier was 1.5? We just change that to 1.5. It's going to automatically adjust. What if the asset's purchase point was not April 1st, but let's say July 1st? Voila, a half year then, it's going to automatically adjust. This is why you use Excel, right? You understand? It's not just Excel is not. there was a student who was not my student actually, but some student, taking an accounting class, and she got this data emailed to her by her professor, and she was, entering the data into the Excel, but that was all she could do. I mean, she could find, with the, for example, if it is, like income statement, right? Or, the operating income, she calculated operating income on a paper and then just, entered that number into the income statement. You understand how, uh, you know, um, time consuming and, futile, in other words, I'm just so, normally she's a very, articulate and, sensible person, but how could she only enter those, data manually? You don't need to enter numbers manually. All you what you enter manually is the only the initial input data. That's it, and then the rest of it is the logic, right? So it was like, she was entering these things all just manually and calculating all these, separately on a piece of paper. What a waste of time and effort, right? You should be cost effective. In other words, resource effective, or resource efficient, right? You should make the efficient use of your resources, and time effort is your resource, isn't it right? And if you set it up like this, this is optimized for the maximum efficiency. And throughout the entire semester, this is what I have been trying to feed you. And by now, if you have digested the reasoning behind it, you may be, blurry on some techniques, but again, that can be all recovered if you review everything we did over the semester, right? But then, if you still think it's just, punching in the number, you missed the entire thing, right? That is very upsetting and, uh, discouraging and, disheartening. But if you have no better understanding and better knowledge or mastery of Excel, uh, then when you started out, it's really, deplorable. Um, but I hope, by now you know what is the reasoning behind all this, and I've been giving you plenty of warnings against the sloppy way they did it in the book. And if you took heed to my warnings, and in homework 4 you would have done it right. Homework also in homework 5 there will be problems that would require making adjustment in the final year. But some people in the past just followed the book and just they completely messed up. I mean, they ended up in a very sloppy depreciation schedule, right? But I hope this time I won't see any work, right? Any homework that would show sloppy depreciation schedule, right? But anyway, so here's the beauty of it. You just change. There's a reason why you have to separate the input data table from the function table, right? Or this is where the model actually mathematical logic is being deployed, right? Or being operated. Data table, right? And then all you need to do is just make a little change in the data table, right? And everything in the function table will all automatically adjust. So here, the last thing is, of course, giving it, a nice outside border so that it would be good housekeeping, right? Now, so we can also extend this to like a longer year, right? So let me do this. Couple of more years, right? And then what's happening? This is going to be 8 years again. Oh, I didn't mean to make it 8 years. Let's make it like, a little less. Maybe 7 years, right? Well, 8 years, fine. Anyway, that's not the point. So then we're going to be doing it like this. All you need to do is simply doing it like this. Then still everything adjusts perfectly, right? Everything adjusts perfectly. Okay, how how beautiful this is, right? It's really, don't you think? It does exactly what it told you to do. Now, suppose with from 8-year example, you're going back to 4-year example. And some people in the past they were copying my template, and it is now 4 years. Suppose it is now 4 years, right? Then what should it be? What should it be? Now it should be in this actually, it should have been changed to year 8. I don't know how it worked out, but still, it's still yeah, it still worked out. 75. Suppose so. This was the one last thing, right? Remember, you cannot do it like this. It's 5-year. Life is 5 years. It's 80 years, and you cannot do it like this, right? No matter what, you will get 175 year. But the interesting thing is, rate is wrong. Everything else is wrong because it's based on 5 years, right? But let's say if it is 8 years, then the correct one is depreciation rate is like this each year, right? Now, suppose we're going back to 4 years, right? Then what do you need to do? You will need to stop. What needs to be done is you will need to stop here. In other words, you will need to delete all of these, and then your depreciation must stop here. If it is 4 years, now it's already done. So 4 years. And here, each year is going to be like this. And then here, it will have to be not this, but the difference between this and salvage value. So in year 4, you will have to, right? And then this has to be exactly this. And then it should stop here. In other words, you shouldn't have anything like this, right? You shouldn't have anything more than year 4. Year 4, you have to stop. But in the past, what I saw was some people copying my template, right? Just kept on going. I mean, 80-year template, and then it is a 4-year thing. So they are stopping already. They should be stopping here. But then they don't stop here. They kept on, just dragging down, and then they end up like this. And the problem is, what do you see? Can the depreciation annual depreciation be a negative one? Can there be a negative depreciation? Negative depreciation means the value is actually, appreciating, right? So this is ridiculous. I mean, mechanically, you end up in salvage value, but it is obviously, it is wrong, right? So there were people who did it like that and not realizing that they did it wrong, right? So anyway, that is the partial year depreciation method in double declining balance method. In this case, it wasn't double. The multiplier was 1.5. So that's the end of all mathematical depreciation method. And the last one is this is non-mathematical accelerated cost recovery system. So this was the guideline by IRS, so IRS, instituted this in 1981, saying if you want to depreciate, accelerated depreciate, right? If you want to accelerate your depreciation, follow this rule, follow this category rule, and the rule is, all the assets fall into like 3-year, 5-year, 10-year, 15-year category. Later, it got modified. There was so slightly different. All 3-year assets depreciate according to this schedule, right? These rates. 5-year assets depreciate according by this, according to this schedule. 10-year asset depreciates according to this schedule. 15-year assets depreciate according to this schedule. Then, actually, if you let me show you. So let me share the PowerPoint. So you see this. Modified accelerated cost recovery system. That's IRS guideline, right? Year one, 3-year assets, 5-year, 7-year, 10, 15, 20 years. So what are what falls into a 3-year category? You don't see any 3-year category here, but starting from 5-year category. Computers, 5 years, heavy trucks, 5-year assets. So 5-year assets all depreciate 20% in year 1, 32 year 2, 19 year 3. This stands for accelerated depreciation system. According to modified accelerated cost recovery system, office furniture, 7 years. Service life, 7 years, right? What else is railroads, 7 years, right? Road cars, right? Not railroads, railroad cars, right? Trains, and individual cars, right? Agricultural and mining equipment, 7 years, right? Chemical manufacturing equipment, 5 years. Offshore drilling equipment, 5 years, right? Clothing manufacturing equipment, 5 years, right? Printing equipment, 7 years, right? So you hardly see 10-year, 15-year assets, right? Equipment to manufacture food, automobiles, right? Automobiles and many other goods, 7 years, right? Passenger motor transport, so cars, 5 years, right? Electric, gas, water generation plants, 20 years. It's a long-lived asset, right? Plants are long-lived assets. Theme parks, even the theme parks, all the rides, roller coasters, those things, 70 years, right? But there were whole previously there were a whole range, but MAs. So that means what? It's not really mathematical. It's simply if your asset is, let's say, car, right? Your car, then look, think about it. Suppose we will have a. So once again, this is a not truly mathematical model. It's just set of guidelines, and you follow. All you need to do is the follow that artificial schedule, right? Predetermined by the IRS, and uh, they published this in 1981. So here, let's take a look at this example. Suppose you have a car, right? Of course, the company vehicle, not your personal vehicle, right? And then the car follows, from the slide, you saw that the passenger motor vehicle falls into a 5-year category. So then this is basically, this is basically the like straight line depreciation schedule, and there's no need for finding. Normally, you would find depreciation rate, but you don't have to do that because the rate is already given. It's predetermined, right? Prescribed. So for life, I didn't put anything. I just referred to this category, right? 5-year category that was predetermined, is already given. And then, so all you need to do is first find the depreciation base, right? You find the depreciation base, which is the difference between the two. And then in year one, all you need to do is simply each year, right? You multiply the depreciation base, and of course you'll have to lock it, right? And then times this depreciation rate each year, right? And you drag it down because the this is locked, right? Depreciation base is locked, and each year, right? The rate is prescribed. You just drag it down, and it will follow there. And then accumulated depreciation is then simply, in the first year it's just the self, right? In the second year, this plus this. And you just keep going like this. Book value, of course, it's always purchase cost minus accumulated depreciation, right? And of course, we lock the purchase cost because it's going to be repeated. You drag it down. What do you see? You end up in the salvage value. Then that means what? You're good. You did, you completed the depreciation, schedule, right? So let me. And the last thing is always, and of course, the housekeeping. Last thing is the housekeeping. So you're gonna need to clear out everything, and then put a nice thick outside border. There you go now, and okay, and this will be right. So there it is, So So then again, if you have railroad cars, medical equipment like uh, MRI machine, CAT scan, just find which category it belongs to, which service life category it belongs to. I have only 3, 5, 10, 15 year categories there, but actually in the MACR there are more categories, even 20-year category, right? Offshore drilling, all these, just find your right category and uh, just build a schedule like this, right? And just apply uh, the given rate, right? So this is it. This is this is the ACRS. And as I said, this is not necessarily. This is not a very mathematical method, right? And anybody can do this. It's just like something for dummies, right? It's like depreciation schedule for dummies, and even a probably fourth grader can do this. Okay, a smart fourth grader can do this. Uh, Alrighty. So that's the end of this. That's the supplement. So please watch this together with the depreciation part 5, video 5, right? Okay, was it 4 or 5? Maybe 5, right? All right. All right. Uh, Stop recording.